5.2 trig functions. So if for some reason you hadn't done the notes yet for this, make sure you do them. I think you should have had plenty of time to do them the day we had the notes day. So anyways, just to be aware of that. There are some identities in this section that you'll need to be familiar with, especially as we move through trig and all of that. And I just realized a couple of things in this section we won't be able to do because, well, anyways. Tomorrow we're going to do the unit circle, which is, if you've talked to Pre-Cal or Algebra 2 at all, the thing that they've been dreading memorizing. It has 66 things on it that you have to know. Anyways, I was originally going to do that today, but we're going to do that tomorrow, and hopefully Traylon will be here for it because, yeah. So basically, if we do it tomorrow, then probably next Monday we'll do a practice quiz. That's the way I always do it. And then on Wednesday we'll do the real one. But if you get a 100 or better, so there's 66 things, I graded out of 64, give a little bit of leeway because that's a lot of things to memorize. Then if you get a 64 out of 64 or better, then you don't have to retake it on Wednesday. But if not, then you kind of know what you don't know. And if you choose to retake it, let's say you had gotten a 63 out of 64, you have to retake it. But let's say that when you retake it on Wednesday, you get a 61 out of 64. I take the higher grade. So now, whatever grade you get on Monday will go in grade link initially, but you can tell your parents, don't freak out. Because it'll be fine because it's going to get replaced as long as you do better than that. And then for probably the rest of Chapter 5 thereafter, you will have a either unit circle given to you on a quiz or a test, or I will give you a blank one and you'll have the opportunity to fill it out for 4 points extra credit on your quiz or your test. So basically every quadrant that you get completely right. And if you miss something on the axis, then I don't dock it from both quadrants. I basically try to lump it so you still get some credit somewhere for some bonus. So anyways, and then I'll give you one of my unit circles. Although y'all's class is small, I can probably grade yours and hand them back to you relatively quickly, but anyways, that's how it works. So, and it's something that if you do decide to go on to Pre-Cal next year, you will have to have memorized, because when you get to an AP exam, they don't give you one, you just have to know it. So, anyways, all the fun stuff. And if you end up taking calculus in college, you'll have to know it still then, so anyways, all the fun stuff. But we're going to do the stuff that doesn't require us to have the unit circle out of this section today, and then once we learn the unit circle tomorrow, we'll do the last 5-10 problems or whatever. And when I say that, they're super fast. It's look at the unit circle, give the value. Look at the unit circle, give the value. We'll do that tomorrow though. So these first ones say to, when I get to the right page, there we go. Sketch an angle theta in standard position such that theta has the least positive measure and the given point is on the terminal side of theta. Then find the values of the 6 trig functions for each angle. Rationalize the denominators when applicable. So obviously we still can't have radicals on the bottom, all the things. So I'm going to give you the SparkNote version of the instructions in just a second. So we've got the point -12, -5. So this point is just an XY coordinate, just like we would normally have. If I told you to just plot that point, that's essentially what that is. So both things are negative down here in quadrant 3. So, and I don't have to be super exact about where this point is. I'm just doing an approximate. You're not actually putting little lines on there and plotting the point. It's just this is in this quadrant. And basically, well, I don't usually do it like that. I usually just get to the point and I stop. So this is going to be the hypotenuse of your triangle. We're trying to graph a triangle, basically. So then it says to sketch an angle in standard position. Standard position means that it's touching the x-axis. Okay, so essentially I'm creating a triangle here with the x-axis where this point makes the hypotenuse with the origin. Okay, so the length of this side of the triangle, this x part, is whatever the x coordinate is here. So this is negative 12. The y value here is negative 5. The x and y values can be positive or negative just depending on what quadrant it's in. It just follows that. But the hypotenuse has to always be positive. Okay, so when we solve for this side, it has to be positive. So standard position means it touches the x-axis, so I'm using this angle here. This will be theta. And I don't normally necessarily draw that in, but if you need to for the visual for yourself, you can. And then what was the other thing it says? That the point is on the terminal side, so the terminal side is just where it stops. So this is just saying theta has to be a positive angle is all it means. So I need to solve for the other side, so a little throwback to geometry. I need the Pythagorean theorem, which, again, I don't necessarily write this every time, but a squared plus b squared, not plus, equals c squared. So the hypotenuse is the c part. Off before it starts solving stuff for me. So I'm going to plug in 5 and 12. It doesn't matter where they go as A or B. It's not going to change anything. So this is negative 5 squared plus negative 12 squared equals c squared. So then I'm going to, in one step, I'm going to take the square root of all this. So the square root of 25 plus 144, which I think is, 169? Anybody know what the square root of 169 is? I'm just curious if you know. What's the square root of 144? Okay. So 1 up from that is the square root of 169. 13. Now, you would have your calculator. This happens to be a whole number value that's going here. That's not always the case. This one is a Pythagorean triple, a 5, 12, 13 triangles Pythagorean triple. But you could just put that number in your calculator. Now, if it's a radical, which we'll have in a minute, you have to leave it as a radical. We don't have like decimal numbers here, but you could have figured out, if you didn't know off the top of your head what the square root of 169 is. You could have checked it and your calculator would tell you it was 13. All right, so now we're finding all 6 trig functions of theta. So I always set it up like this, and I would like you to do the same. So we do sine, cosine, and tangent, and then we're also going to have cosecant, secant, and cotangent. And I just use theta. If you want to use x, that's fine. It's not going to change anything about your answer, but some people like to use x instead of theta. So sine is, and this is just again a throwback to geometry. We've done the new part where we've set it up, is opposite over hypotenuse. So this one is negative 5 over 13. Cosine is adjacent over hypotenuse, so negative 12 over 13. Then tangent is opposite over adjacent, so that's negative 5 over negative 12. The negatives cancel, so that's just 5 over 12. Now, cosecant, secant, and cotangent, the reason I set it up this way is because I take whatever I had for sine, cosine, and tangent, I go across here, and I just flip the fractions over. Okay, so it's cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and then cotangent is adjacent over hypotenuse. So they just flip, so that's why we can do that. So this is negative, and the negative doesn't matter if it goes on top, on the bottom, just out front. That doesn't change anything as long as it's negative. So 13 over 5, negative 13 over 12, and this one is just 12 over 5. And so this is your answer to this question. And so as long as you have it set up like this, you don't have to like box it. I mean, sometimes you'll see me do like a giant box around it, but usually it's pretty easy to see where it is, so I don't have to worry about that too much. Let's see. 16 is the point 15 and -8. And I'm also going to tell you, by the end of chapter 5, you're going to be very tired of doing these because, and maybe even into chapter 6, we do these like pretty much in every section. There's like a little bit that we do with these. So you're going to become experts at these by the end of chapter 5. Just because for some reason they put them in all the sections. So I'm going to set up my little coordinate plane. Doesn't have to be anything super big. So this is 15 and -8, so that means my x is positive, y is negative, so it's going to be down here. So I just put it in like that, and then touching the x-axis, so it'll be there. So I've got 15 here, -8 here, and then I got to find the hypotenuse. So a lot of times I'm going to tell you, I will go ahead and just write it like this. C is equal to the square root instead of writing like a squared plus b squared, because I did this one up here in like multiple steps. I will almost always go straight to this step right here when I'm doing it. Now, it's up to you if you need to do that or whatever. But this is 15 squared plus, and since squaring it's going to make the numbers positive, I don't even need to write the negative. If you want to, just so that you don't forget the number was negative, you can. I think 15 squared is 225, but I don't know that off the top of my head. So, yes it is. Okay. So this is the square root of 225 plus 64, which is the square root of 289. Might be a perfect square. Let's see. The first thing I'm going to do is always see if it's a perfect square. A lot of times they'll come out to be. So yeah, this one is. So this is the square root. Nope, not the square root. I lied. This is just 17. So again, this is another Pythagorean triple, which you don't have to know that. Just if they come out to be whole numbers, they're triples. Anyways. Like a 3, 4, 5 triangle is another one. Anyways, they're all different ones of them, but so now I set it up, and again we're using this angle here. It's always got to be the one at the origin. All right, so what would sine be for this one? Opposite over hypotenuse, what would that be? Yep, -8 over 17. What about cosine? 15 over 17. And tangent?
-8 over 15.
Yeah, opposite over adjacent, so -8 over 15. You just already told me this one. And then for cosecant, we just flip sine, so -8, and secant, we flip cosine, so 17 over 15. And that's our answer for that one.
Is going higher than that?
Yeah. Okay. One other thing with this stuff that I want us to see, it's a little different. These are called quadrantial angles when this happens. But if either of these numbers is a 0, that means it occurs on an axis. Okay, so in this particular case, do you know where this one is? Where's the 0.05?
The x or y axis?
Yeah, the y-axis, specifically the positive y. So it's up here. So I can't make a triangle with this one, right? Because it have to be touching the x-axis. And now, if the point was on the x-axis, I still can't make a triangle because there's no angle there if it's just on an axis. So what we have to do is we still find our hypotenuse value, okay? But when we do that, we've got, let's see, 0 squared plus 5 squared equals c squared. I need to look at something really fast. I think I know what's different about this. These are quadrangular angles, but I'm thinking of something different. All right, so when we do this, this ends up being c is equal to, take the square root of that, 5. So this means x equals 0, y equals 5. And typically when we're looking at the hypotenuse, we call that r. This is also 5. So just as a little refresher, sine is y over r, cosine is x over r, and then tangent is y over x, okay, which I think those were in your notes. But I'm going to use that as I go through and find all 6 trig functions for this one. So sine is y over r. So that's 5 over 5, which is equal to 1. Cosine is x over r, which is 0 over 5. And what's 0 divided by 5? 0. And then tangent is y over x, so 5 over 0, which is what? What happens when I divide by 0? Undefined. So then cosecant is this flipped, so 5 over 5, which is just end up being 1. Now secant is 5 over 0, which is again undefined. And then, I don't really have room here, but cotangent is 0 over 5, which is 0. So when the point occurs on an axis, your answers are always going to be 1, 0, and undefined in some combination of those things. That's how it has to happen, okay? So if you have a 0 here, the answers have to look something like this. It's going to be some combination of 1, 0, and undefined because things are going to cancel when that happens. Okay. The thing that I was looking up was in the Algebra 2 book, they actually give you the angle. So they would say like this is 90 degrees and then you have to figure out these values, which is why I was looking at it. But anyways, ours does it a little bit different, but I just want you to see that. So any questions on that? And that'll be if it's on the X or the Y. So, all right, so a few things we're skipping because we haven't done the unit circle yet, but I'm going to jump down well, I'm going to jump down a lot. I'm just going to warn you. To problem 140. So these ones say still to give all 6 trig function values for the angle theta, rationalize the denominator if applicable. So this one is, they tell us cosine of theta is equal to negative 3 over 5. And then they say, and theta is in quadrant 3. And they give it to us in Roman numerals, so hopefully you know those. All you have to know is 1 through 4. Alright, so they have told us that cosine is negative 3 over 5. The reason that it is relevant what quadrant it is in is not so much when we have sine or cosine, but if they gave us tangent, it would make a difference, okay? To know what x value, like if x is positive, y is positive, or x is negative, y is negative, whatever. But with cosine, it's adjacent over hypotenuse. Hypotenuse always, always, always has to be positive. So in this case, I know, but quadrant 3 is still telling me where to draw it. So in the other ones, they gave us a point, like this one was in quadrant 4. And so that was positive, negative, and so it's just a different way to give us the same information, basically. So I still set this up as a little mini graph here. Quadrant 3 is over here. So in case you need a refresher, this is 1, 2, 3, and 4. So we still draw it touching the x-axis. This is still my angle here. So cosine is adjacent over hypotenuse. So in this case, I know that both x and y are going to be negative. In quadrant 3, both values are negative. So this is negative 3, and my hypotenuse is 5. So I need to find the other side, which is, in this case, I'm solving for one of the sides. So I'm just going to say a squared is equal to c squared minus b squared. Okay, so that's just the hypotenuse minus one of the sides. So a is the square root of 5 squared minus negative 3 squared. So that's 25. Whoa, it's running away. 25 minus 9, which is 16. Square root of 16 is what? 4. So this side value over here that I just solved for is 4. Now, this also happens to be a special type. It's a Pythagorean triple. Now, this is the other reason that it matters what quadrant this is in. Okay, this side length is 4, but it's down here in quadrant 3, which means my y value is negative, so I need to make this negative. Okay, so that's the other reason that we need the graph there for us, so we make sure we get our values correct for positive and negative. So sine of theta, cosine theta they gave me, so I usually will go ahead and write those in as I'm going. And I still want you, even when they've already given us a value like that, I still want you to write it. I still want you to give me all 6 together. Okay. And then cosecant, secant, and cotangent. All right, so sine is opposite over hypotenuse, so negative 4 over 5. Tangent is opposite over adjacent, so negative 4 over negative 3. Both of those are negative, so it just becomes 4 over 3. Cosecant is hypotenuse over opposite, or I just take sine and flip it, so 5 over negative 4. Secant, I flip this one, so negative 5 over 3. And since they gave me cosine to start with, I can be guaranteed to get secant right because I just flip it. And then cotangent, flip tangent is 3 over 4. And that's all we have to do for that. Not too bad, right? All right, one more of these, and then I'm going to choose a few problems out of the stuff that we've already done for you to do, and then tomorrow we do the unit circle and add on the last couple of things. You'll just add it to this assignment, so you won't have to, you will just turn in one, homework assignment for this section. 144 is the cosecant of theta equals 2, and they tell us theta is in quadrant 2. All right, so cosecant is not one that I'm super familiar with working with. So what I like to do when I have something that's either cosecant, secant, or cotangent given to me, I actually like to go ahead and set this up and turn it into whatever trig function I am familiar with. So either sine, cosine, or tangent. In this case, cosecant goes with sine, so obviously I'm going to be working with sine. So I know that it's going to occur in quadrant 2. So if I want to go ahead, and graph this, I can, and just set up my little triangle here. But I want to turn this into sine so that I have an easier time working with it. As long as I've done this stuff, I still think it's easier to turn it into one of the ones I'm more familiar with. So cosecant is 2. And what we need to remember is that anytime I have a whole number like that, it's technically over 1. Okay? So sine then is going to be 1/2. Okay, so I just flip it. So now this is opposite over hypotenuse. So opposite is over here. So that's 1. Down here is 2. Now I'm going to see, do these numbers ring a bell to you? These are the values of a special type of triangle.
A Pythagorean triple.
No. You remember special triangles, 45, 45, 90, 30, 60, 90?
Oh, yeah.
Do you remember what the side length is to this one? This one's a 30, 60, 90. If not, it's okay. I just like seeing if classes remember. My class the other day was super excited because they, as soon as I put the numbers up there, they were like, we know what that is. I was like, well, I'm glad. So it's root 3. Now, if you didn't recognize that, obviously we could use the Pythagorean theorem and find it. Now, what have I not accounted for here? Yet.
Negatives.
Okay, so out of those things, so that's the other thing I've got to really be careful and watch for. I also just realized I put these numbers in the wrong spot.
Yes.
Okay, hold on. This is root 3. This is 2. I was like, those numbers are not right. I was like, because something would have to be negative there. So which number should be negative here? Yep, root 3 should be negative. Hypotenuse is always positive, and the x value in this case, or not the negative, the y value is on top, so it's positive. So it's 1, 2, and negative root 3 are my values. So now, what would the cosine of this angle here be? So adjacent over hypotenuse.
Negative 3 root. How would you say that?
I usually just say negative root 3.
Negative root 3 over 2.
Yep. I usually just say root. Some people will be like, square root. And I'm like, okay. But I just do it to say it fast. All right, then tangent is opposite over adjacent. So what would that be?
1 over negative root 3.
So, I don't know why I did that. 1 over negative root 3. Now, we can't leave a radical on the bottom, so we have to rationalize it. So we multiply by the square root of 3 over the square root of 3. So that's the same thing as multiplying the whole thing by 1. And when I do that, I'm going to make sure I don't forget my negative. So negative there. On top, 1 times the square root of 3 is the square root of 3. On the bottom, the square root of 3 times the square root of 3 would be the square root of 9, which is 3. So anytime you multiply like the square root of 2 times the square root of 2, that's equal to 2. Okay, basically the square roots just go away when you do that. So this is negative root 3 over 3. Now, as you get more practice, you may be able to go straight to this answer, which is fine. The main reason that I don't is because when I flip this, if I flip my final answer, I'm going to get 3 over negative root 3, and then I've got to rationalize it again, okay? If I use the original that I had, so this 1 over negative root 3, and I flip that, I just have negative root 3 over 1. I don't need the over 1 part. So it's nice and easy. I don't have to go back and do extra math. It's up to you how you want to do it, but I like to have the original so that I can just flip it and not have to re-rationalize it. It's not hard. It's just another extra step that you can avoid if you can help it. So then over here, when I flip this one, I'm going to end up with negative 2 over the square root of 3. I've got to multiply this by the square root of 3 over the square root of 3. So when I do that, I get negative, it's about to run off the screen over here, 2 root 3. And so remember, when I'm multiplying a number times the square root, it's just the number times the square root. It doesn't like get multiplied inside. And then square root of 3 times the square root of 3 is just 3. So negative 2 root 3 over 3. So these values, specifically the sine, cosine, and tangent values of this, are going to look really familiar tomorrow when we do our unit circle. Those are going to be some of the super common numbers that we're going to see on our unit circle. So anyways, just so that you're aware of that. As far as problems for what we've done so far, I don't even know. Let's see. And like I said, we're going to do more tomorrow with it. So if you don't finish, you don't need to do it tonight or anything like that. You'll have time sometime tomorrow when we're done with the last stuff that goes with this section. But the problems are, let's see, 13, 17, and 21 from the first stuff that we did, and then from what we just now did. Let's do 139 and 143. And they'll probably just be about 5 or 6 more problems that we'll add on tomorrow, but they'll be like quick math problems. These are the long ones here. So anyways, any questions about anything we did today? I know it's like a lot of new information. So it always has to touch the x-axis. And then based on what quadrant it tells me is how I know where it's going. So the options, that's a really good question. I forgot I was going to do this. So our options for how our triangle can look anytime we're doing a problem like this is it can look like this. If it's in quadrant 1, it'll look like that in quadrant 2. And obviously I'm not drawing these proportional for any reason right now. In quadrant 3, it'll look like this. They're slightly sliding from the x or from the origin. Just know they're supposed to be at the origin. And then down here it would be like that. So if you drew one in every quadrant, it should look like a bow tie. They don't touch the y, they always touch the x. But that's how they would look when you're all done.